Whenever you're ready.
Oh, okay. Uh, Hello, everyone. Uh, Thanks, Jia, for that introduction. So let's get started. Yeah, the topic is beyond the books, becoming a data scientist. Um, so just before getting everything in, I'll just talk a little bit about myself, just to set a context of what is really happening in this meeting. Um, so I was also like just a normal college-going kid, um, trying to figure out what to do, what not to do. I was pursuing engineering in India. And if you're from my native place, you probably know why that's such a common path. Um, while studying engineering, specifically computer science engineering, it didn't click to me as intuitively as I had hoped. Like, no offense to any lovers of computer science engineering there, but I say this not to like criticize the field, but to express that for me personally, the intuitive connection to problem statements beyond just connecting dots for a solution was kind of missing. Throughout this presentation, I want to make it clear that I'm not here to demean any book, right? Or suggest that you shouldn't read if you want to become a data scientist. I guess you should read and you will read a lot when you want to become a data scientist. However, there are like certain aspects that book often don't teach you. There are some real world elements of what it takes to become a data scientist. What I'll share today are some simple but important things that I've discovered during my journey as being a data scientist for like 2, 3 years now. Speaking of my journey, as I mentioned earlier, I was a regular college student, not particularly passionate about computer science, but still studying it. In my third year, however, I discovered like data science, which truly clicked for me, specifically because of its mathematical intuitiveness. From that moment, I kind of told myself, this is what I want to do. I'm committed fully to learning it. Eventually, I landed my first job as a data scientist in advanced analytics team at Cummins. It's a company based in Columbus, Ohio. I was working at their office in Pune, Maharashtra, and kind of stayed there for like 2 to 2.5 years. Later, I decided to master my skills, move to US, the hub of data science today, to continue learning and growing. I pursued my master's in data science and had the opportunity to intern with Microsoft Xbox as a data scientist intern again. Now I'm working full time as a data scientist with Xbox Game Pass Analytics team. Um, this presentation is about sharing what really it takes to become a data scientist in a way. Um, Beyond just that, uh, what the books tell you, and I hope I do a good job at that. I'm just sorry, my phone is just so sorry for that. Okay, let's dive into it. Um, so my first and the most important finding was understanding the fundamentals during your academic journey. And I want to kind of double emphasize the word understand. Too often, I've seen people memorize the fundamentals just to tick off the box and move on. But they don't ask why. That's the one biggest reason many people don't become a good data scientist and a better data scientist as they could be. Uh, that's the gap, the difference between someone being a data scientist and someone becoming a better data scientist. So while you are in academia, I strongly urge you to go deep into the fundamentals. This is the time where you actually have the luxury to dive deep as much as you want, to ask why every time. If you're trying to understand an approach, a model, a theory, or maybe a simple mathematical function in supposed to what you're learning in data science, don't stop at how it works. Ask why it works, ask why it's done that way, ask why not a different way. Now, of course, don't get lost in asking why infinitely, but be smart about it. But uh, having that raw, deep understanding will absolutely put you ahead of the game. One very effective way to do this is by applying fundamentals through raw code. For example, let's say you learned about decision trees. And I assume many of you already are familiar with what are decision trees. You know, it's based on information gain and that it splits features based on that and makes predictions accordingly. That's really great. But now ask yourself, can you actually explain what's happening under the hood? A fantastic exercise is to write your own decision tree from scratch. It's not that tough, to be very honest, when you start with it. And from loading the data, calculating the entropy levels, to building the tree, when you do that, you'll finally see what's actually going on underneath the library functions. And that's the level of confidence, what truly sharpens your fundamentals. And this is just one example. You can do this with theorems, models, any optimization techniques, any complex model you can think of. Write them out, test them on real data, observe that behavior. Take any data set from any source and apply these fundamentals to it using your own raw code. See how the data responds. Definitely, this practice will internalize concepts, not just memorize them. After that point, you're not just kind of repeating definitions. That's what I've seen a lot of people do. You are actually understanding them. You'll be able to answer questions analytically and intuitively, not just academically. You won't say random forest helps control overfitting. You will be able to explain why random forests help and control overfitting. And that, my friends, makes all the difference. Just try the example prompt in ChatGPT and you'll see what I'm talking about actually. Now, with this process of truly understanding the fundamentals, what will start happening is you will start developing two critical skills, and that is an analytical mindset and engineering proficiency. And honestly, these two skills are among the most important if you want to be a really good data scientist. Someone who not only helps the company, but also helps themselves to grow in this field. Now, unfortunately, there's no magic prompt that can instantly develop an analytical mindset. That takes time because it's a process. You go through the fundamentals, you apply those fundamentals to the data, you observe the patterns, you think analytically about those patterns, you go back, apply those fundamentals again, observe, and you repeat this exercise again and again. And over time, you'll start building an instinct, understand the why, when, how, and where your data behaves related to the fundamental behavior or theories. And this type of mindset is absolutely critical uh, to being a successful data scientist in the world. But the fact of the matter is, no offense to computer science engineering again, but you're doing a huge disservice if you approach a data science problem purely like an engineer. Similarly, if you flip it and approach a pure engineering problem, if you apply it like a purely like a data scientist, you're also making a big difference. But the point of the factor is you need to understand the difference. In data science, your focus needs to be on analyzing data first, not just engineering a solution. A lot of people fall into the trap of trying to over-engineer solutions without properly analyzing the data. And that analysis is actually the most critical part in the whole real-world problem. But I want to be honest, I mean, it's not easy. It's legit easier said than done. Uh, Many times it happened to me too. You can get overwhelmed by all the fundamentals in your head, and you kind of forget to think analytically about it. But if you stay disciplined enough, if you apply your fundamentals to real data repeatedly, it will slowly build the first layer of analytical mindset. One simple and more practical way to go about it is go to Kaggle, go to Google Datasets, go to ChatGPT or any AI service out there right now, and ask them about any fundamental and tell it to give you a data set about it. It will actually give you a data set. Write your fundamental code. Let's say, for example, you want to write a fundamental code to understand logistic regression. You write a fitting of logistic regression, you write a training of logistic regression, and you write a predicting of logistic regression. Run it, plot it, observe how the data behaves, see what works, see what doesn't work, analyze it, ask why at every step. Repeat this process, and trust me, this practice will not only create a stronger analytical mindset, but also an engineering precision, both of which hand in hand will truly make you a better data scientist. I believe you must have heard this from a lot of sources, and this is kind of very common to say for every data scientist or any guy who is working in machine learning, deep learning, and whatnot, to say EDA is the most important thing. And the most absurd behavior I see from the aspiring data scientist folks is they directly just run into models and don't understand what is their data about. This is where exploratory data analysis comes into play. You must have heard this phrase like from a lot of data scientists, right? 80% of our work is EDA and 20% is modeling, engineering, and everything else. But well, it's true. But what I often see is aspiring data science don't really believe it. They don't want to spend time understanding the data because they know how to build models. They just want to quickly fit models and see the predictions and results from their problem statements. EDA is where real insights are born. That is why I personally focus so much on EDA whenever I work on a project. And I feel every aspiring data scientist should have that tendency to do so. EDA helps you to understand hidden patterns, catch anomalies, discover relationships, all of which your model will actually rely on when it's learning from the data. If you skip EDA, you don't really kind of understand your data. And if you don't understand your data, you don't really understand the solution you're building. And that's just wrong as a data scientist, if I can say. Understanding the data should be your first priority always. EDA also helps you proactively catch data quality issues, which is massively important before you even think about modeling. But even beyond that, and this is critical, EDA builds your intuition about the data, an intuition that no machine learning model can replicate. Always remember this point. Your brain is the first model you're working with, and your brain is the sharpest model out there. When you're doing EDA, you're actually training your brain, the sharpest model on that data set. The better your EDA, the sharper is your understanding about the data set becomes. And only then you can kind of build a truly powerful machine learning or a deep learning model on top of it. So like extremely inquisitive about the insights you gain. Repeat the EDA process again and again to continuously refine your understanding. Just to end this slide, right, I'll just say if I were given 1 year to solve a problem, I would easily spend close to 11 months on EDA because I know if I do that, I'll be able to solve the problem beautifully in the final month. Now, let me switch gears a bit towards kind of corporate level understanding of what being a data scientist means. One key factor that I found missing across all academia was understanding domains and applying fundamentals to domain specific data. Uh, I like to think about it in this way, right? I have my sword of data science fundamentals, I have my sword of probability, I have my sword of statistics, I have my sword of linear algebra, and many more swords for techniques and models and tools, right? But in this war, so to speak, the first battle is understanding the domain. You have to understand your enemy first before choosing the right sword. Similarly, if you have to understand your domain before applying the right techniques, before choosing the right sword. Let me give an example from my experience at Cummins, which is a combustion engine company. There I've worked with data around fleets of trucks, sheets of engine level data, pressure, temperature, and so many other metrics. But before I could even model anything, I had to understand the domain of combustion engines because data is always contextual. One feature means in one domain could mean multiple things in different domains. A metric that's critical in one field might be totally irrelevant in another. When you understand the domain and you master your fundamentals, only then do you know which sword to pick up. You start answering key questions like, is random forest a good choice here? Would an ensemble method perform better? Should I even use boosting, or maybe a simple logistic regression is more suited? Are assumptions of SVM kind of valid here? You start tailoring your model choices very, very wisely, aligned with domain-specific constraints and requirements. And make no mistake, domain-specific constraints matter a lot. Your assumptions, your validation process, your success metrics all completely depend on the domain you're working in. One very popular example, even in academia, it's shown that in healthcare, precision is often the key metric, and in fraud detection, recall becomes the more important metric than a precision. There are so many such examples and so many metrics, but the key mindset is always think domain first. One really good practice I highly recommend is, once you're confident with your fundamentals and once you start developing an analytical mindset and you have confidence about an analytical mindset, start building EDA notebooks on Kaggle. Pick a data set, various domains, read about the domain, understand the problem context. Because in the industry, you will be expected to understand domain very quickly. Work with it, apply your fundamentals, and deliver actionable insights to stakeholders, often under very tight deadlines. And in this small window, you will be expected to understand the domain, perform EDA, build your models, do inference, and present the solution clearly to your stakeholders. And if you don't understand the domain, you will struggle. Simple as that. When I started working as a corporate world, when I started working in the corporate world, understanding the domain first was the first and the boldest lessons I learned. It was practically written in capital letters in front of me. So I kind of strongly urge you, if you want to be a specialist, learn one domain really deeply. That's really cool, to be honest. If you want to be flexible and successful across industries, develop the ability to understand new domains fast. Because being domain agile will truly make you stand out as a data scientist. Now, when you start working in corporate, one key reality you will face is every organization has its own unique data model. In short, in school or projects, the process might be very, very straightforward: cleaning, EDA, modeling, evaluation. But in real world companies, every team has a different data model in place for their data scientists and data engineers to work on. So what do you do with so many different models out there, right? The easiest and the smartest approach is know the business objective, understand the data flow, understand the relationships, interpret the model components, define your own steps: data cleaning, EDA, modeling, evaluation, interpretation. And each of these steps can have many subsets, and subsets can also intermingle with each other. For example, cleaning itself involves missing value treatment, feature selection, data augmentation, whatnot. EDA could involve feature engineering, visualization, analysis on correlation, anomaly detection, and so much more. Modeling can be actually a summation of cleaning and EDA on top of making traditional ML, deep learning, or even hybrid technique models. Pipelines are messy in real world settings, but understanding the pipeline architecture is very, very crucial. Because in corporate, you're not just handed clean table to just model, right? You must create that clean table first. Query the language, query the table, query the data very nicely. But even beyond that, architectural thinking is what that matters. Many aspiring data scientists dislike working on data models. They love making models, they love analyzing data, but they don't love understanding messy real world data models. Your stakeholders expect you to solve a business problem, not just a data problem. You're building models for business value, not just technical accuracy. A simple, stable model can be built by anyone in today's world. You are expected to build a complex, high business value solution. That's the main difference. And how to build this skill practically? One thing which I did on my own was go out there in the net, search for different data models. For example, Netflix recommendation engine system, Airbnb search ranking model, Spotify playlist generation systems, fraud detection systems in banks and PayPal and whatnot, right? There are so many data models out there for you to understand. And by reading how real data pipelines and models are created, you will naturally understand how data models are designed and evolved. When you enter corporate, this exposure will help you quickly grasp any organization's data model, and you'll be able to start analyzing and modeling quite immediately, which will definitely kind of uh, make you ahead in the game. So till now, we have talked about fundamentals, we've talked about understanding the domain, we've talked about data models, and there's one very important piece that we have not really dived into yet, and that is how you choose to convey your solution. Um, Honestly, this was probably the second biggest learning for me in my journey as a data scientist, realizing that solving the problem is only half-time job. Conveying the solution properly is equally, if not more important. In the real corporate world, your data science team will always have to present directly to the stakeholders. There is no middle person between you and them. You are not communicating indirectly with them. You're just directly communicating results with them. And here's the thing, your stakeholders don't really care about what data science is. They don't care about what is redundancy in your data is. Uh, they don't even need to know. Their focus is business decisions. Your focus is making them understand your work without needing PhD in statistics. That's how I used to think about it. Um, so how do you do that? A very simple breakdown which I follow, which I'm sharing with you guys, are like is very simple. One is start with the business objective. Always write that business objective everywhere, wherever you're staying or wherever you're working, right? Always remind yourself, why are we doing this? What's the main problem we are solving? That needs to be crystal clear with respect to your stakeholders. Number two is translate technical work into your business language. This is the most crucial point where every data scientist fails, and it's still very tough to do. No fancy algorithm names are needed, no model parameters, but translate your work into terms that business leader can connect with. Show your solution that addresses the original business problem. Connect the dots back to the objective every time. Whenever you're kind of explaining your solution should connect the dot back to your objective every 2 or 3 times. You can get a number on it when you completely keep on doing it again and again. And visualize smartly. One of the best quotes I've heard about visualization is every drop of ink on the chart should speak a meaning. Um, do avoid clutter, make your graphs simple, intuitive, and powerful. Use dashboards if needed, but don't overcomplicate. Now, one more very important thing is tell a story. A lot of new data scientists completely overlook this, especially because in college and during projects, you are so focused on building models and getting good results. But in real world, storytelling becomes kind of the key than just good results. Without story, your work has no life, you can say. So you should always build a flow. First, state the problem, show your approach, present your insights, and finally show the impact your solution can create. Use relatable examples whenever needed, things that your audience can instantly understand. Tailor your language based on the room and who you're speaking to, always. Uh, you should understand your audience first before making them uh, understand your solution. And they don't want to know your technicalities. They want to know your methods, your metrics, and your models. Most importantly, they want actionable outcomes. So whenever you are trying to introduce a solution to any problem statement, uh, show them that your model is not just giving random insights. It's actually guiding them to a certain and confident decision making. Finally, two of the golden rules that have always helped me is less is more. one big mistake every data scientist out there does is they show everything what they have done from the very start to the very end because they have worked so much hard on that problem statement. They want to show everything what they have done, and that's very fine. Everybody wants to do that, but the skill is only showing absolutely necessary what is important to drive, uh, keeping the rest ready for questions. For example, if you train like 15 models in a day, show only one model out of that. Keep the 14 in your arsenal to answer more questions with respect to that. Second, always ask yourself, can a 5-year-old understand this? Your first draft of your solution should always be, can a 5-year-old understand the solution? If yes, you're doing it right. If not, simplify further and further and further. Because your goal is to make your insights obvious, intuitive for everyone, not just for data scientists. In short, your job is not just to create great models. Your real job is to communicate the solutions that drive more business impact. That's when your work becomes truly valuable in kind of a corporate setup. Now, talking about understanding domains, talking about conveying your solutions, talking about understanding data models, all these are extremely important in the corporate world. But there's something that's even more important than all of that. Uh, you see the photo there? Uh, that the guy's name is George Box, one of the brilliant statisticians we have ever had. And his most famous statement is something you've probably heard before. It's called all models are wrong, but some are useful. Now, I want, I mean, let that sing for a second. That's very, very important statement for every data scientist out there. That one line, it captures so much about what it really means to be a good data scientist. Because George Box knew better than anyone the importance of being critical of your own work. The reality is, whatever models you're building, they're not magic. They're not predicting the future. They're not, so to speak, they're not predicting the future. They're not fortune tellers telling that you're going to be rich next year, right? I wish they could, but unfortunately, that's now how it works. Models only learns pattern from your data. They use those patterns to estimate probabilities or predict averages around mapped points. That's it. They're making best possible guess on what they have seen before. And that's why it becomes your responsibility to be brutally honest about where your models falls short. You have to identify weaknesses, proactively address them, and keep working to strengthen your solutions. One of the biggest academic failure you can do to yourself is to become overconfident about your models. Um, don't fall into that trap. Uh, be very critical about your models, uh, as it's the first step towards becoming a truly good data scientist. Now, I know the feeling. You build a model, right? You build a good pipeline and you start predicting about things. It feels so good that you have made this baby out of it, right? Um, but when that excitement settles, the real question you need to ask yourself is, am I being too opinionated about my solution? Can I make this even better? Because the truth of the fact is, no data is perfect. No model is perfect. All data is wrong. All models are wrong. But some models are incredibly useful. So learn to criticize your own work. Learn to criticize your understanding. Learn to criticize your fundamentals. Learn to criticize your EDA. If you can develop that critical analytical mindset uh, while you're still in academia, then trust me, you'll become an outstanding data scientist when you step into the real world. Now, this is a very rough slide. Okay, sorry for that. But uh, now we have talked a lot today, right? I've talked a lot today. I usually don't. Um, but we have like covered so many important aspects of data science that matter when you kind of step into the real world. But before I wrap up, I want to share something a little different, something a little bit close to me, um, that I learned from one of my teachers during my own time in academia. Um, and honestly, it stayed with me because it's kind of true, right? Um, One simple experiment you can carry, and if you're a data scientist, please carry out experiments a lot, right? Uh, Very simple experiment is, take 10 data scientists from your network, not from the same domain though, but from different domains, right? And just ask them one simple question. What is data science? Don't kind of cheat yourself. Listen to each answers very carefully. And if, and this is a big if all 10 of them answers in the exact same way, I'm pretty sure I can stop doing data modeling, because then everything will be similar, right? As you can just lead it in one day and I'm done. Because the truth is, nobody can define data science in just one way. And that's why even today, there's so much confusion. What is data science? What is modeling? What is machine learning? What is AI? All these terms, they are floating around, overlapping and evolving every day right now. Uh, so in this chaotic, fast changing space, the best thing you can do is, after learning all the fundamentals we have talked about, um, is actually very simple. Uh, know yourself. You'll often see this segmentation: data business person, data creative guy, or anyone, data researcher, data developer. You'll hear about the skills: being good at statistics, being good at math, being good at business, being good at machine learning, at programming, at big data. And yes, all of those matter. But at the end of the day, you need to make your own definition of what being a data scientist mean to you. For me personally, my definition is simple: exploring the science behind the information. And trust me, it took me quite some time to arrive at that line. It wasn't overnight, because maybe you are strong in statistics, maybe you're strong in machine learning, maybe you love data engineering, maybe you are brilliant in business strategy, maybe you're a brilliant business strategist, maybe you're an amazing visualization expert, maybe you are really great at GIS. Whatever it is, there is a place for you in the field for sure. Uh, but before you chase all the tools and buzzwords, before you can chase every new thing coming out, take a moment, ask yourself, who am I as a data scientist first? You can do this after mastering all the technical steps we have discussed, or you can do this first and let it guide your learning journey. Honestly, the order doesn't matter, but answering this question for yourself, that is something every data scientist must do. In the end, if there's something you can carry with you from all of this, let it be these three simple, maybe powerful ideas. First, don't be opinionated, be critical, be curious, let the data guide your decisions, not your assumptions. Second, learn how to learn. In this field, which is moving at a lightning speed right now, your real superpower is your ability to adapt and keep growing. So stay ahead by staying curious. And third, remember that true understanding brings true confidence. When you deeply understand your work, that's when the real fun begins. Because data scientists who truly understand their craft can create brilliant and meaningful solutions. Uh, my end line will be, thank you for listening to me here, and thank you for the invitation. But my end line will be, definitely in your academia, you will train like 100 models and 400 models and 500 models, and I hope you do. After that, train that very one linear regression, like very rightly, and be satisfied with it. Yeah, for that, thank you so much.
Thank you so much. That was such a helpful talk, especially for those who are participating in the datathon. I think this is a good chance for everyone to ask questions. You can either unmute yourself or type them in the chat. Any questions you have for Raghav, including what he talked about, anything about, his career, his journey. Yeah.
So I need to open chat, right? I guess.
Yeah, I can also let you know if someone types anything in the chat.
Okay. Can we take an example of a data set available in any industry and proceed with it? Yes, you can. Yes, you can. That's the best way to go for. I used to go for Kaggle a lot, but Google Datasets is also a good site. There are so many sites out there. Now, in today's world, even ChatGPT gives you synthetic data for understanding a lot of things. So you can start with anything, definitely. What do companies prefer to look for in an intern? That's a good question. Um, uh, I believe they want to see how much you are really into your own field. A lot of people, what they do is they have multiple things done, so their resume don't kind of outshine the work. And it's not very clear for the company to understand that is this person a data scientist or is this person not a data scientist. So I feel your resume is the first um, paper which is seen from the company for you. um, Focus on that more, and make projects. Projects are something which will definitely stand you out. Uh, what are some good questions to ask myself when I want to make my visualizations useful and provide actionable suggestions for my audience? That's a good question. Uh, Everyone makes their own visualizations. There is no hard and fast rule to do so, right? Uh, what I can tell you is when you start making or creating EDA notebooks, you will start actually have your own pattern of doing EDA. Everybody develops that. This is my pattern of doing EDA. This is your pattern of doing EDA. That is more important than just doing visualizations. Visualizations comes after that because visualizations are the way when you are trying to um, explain your solutions more well, right? Uh, so understanding your solutions will give you better visualizations, definitely. Are there any other habits of data scientist students that you would recommend not doing? Oh, so many. Uh, but if I can think of one more, is not using your academia in your work. A lot of people just start going for production environments so much that they forget about their academia. So don't forget about academia. Use your academia in your work so that you can grow as a data scientist every day. Um, Based on the characteristics that you mentioned in your presentation, which one would you prefer? Would you start for a complete beginner? Statistics, programming, or any other ones you mentioned? It depends on you. I start with my strong suit first. So I was a computer science student, so I started with programming first, and then I went with every other thing. But it depends on you. If you have a background in something else, start with that first, and then slowly come into the field. That is what is the best thing you can do for yourself. Definitely.
I have a question.
Oh yeah, yeah, go ahead.
Can you hear me?
Yeah, I can hear you. I can hear you.
So I'm actually an e-learning specialist, and I took part in the two prototons. And I thought it was always so great, so I decided to take part in the datathon, although I'm a total newbie. And one thing I realized is my learning type, my brain. So it's not inductive, it's deductive. So you start with the big picture. But usually I'm best when I have a huge picture, like a huge sample of examples. When you show me 100 examples of something, I can learn best. And this is like I'm not good. I had statistics in my business school and all that, and I have not managed to master coding yet. But where do you see a cross benefit of this understanding the data inherently, like intuitively, but not mastering the tools?
Okay. Um, so if I can answer that, uh, there there is an understanding of data science which will never make you use tools, but only your intuition and your solution building can make you go forward. Uh, in my perspective, what the best thing what everybody can do is understand not just based on tools, but understand the intuitivity of everything first and start applying them on data without using any tools per se. You don't need every time the tools to understand what is really happening. Uh, but as you can say, you read a lot, right? Read on the solutions which are out there a lot, and that will make your understanding much more and more better. And maybe in coming future, you'll be able to uh, give out solutions which no other data scientist can think of. Another game which you can start with is go with a domain, go with a single domain and be a master of the domain. When you become the master of the domain, you will not become just a data scientist, but a term called subject matter expert on that domain, which is even more important uh, to be as a data scientist. So I think that can be a good starting point, definitely.
Okay, thank you.
Does anyone have any more questions?
Yes, I have one. So I would like to ask whether I currently work at Amazon too. Is there any way I can get internal transfer to data scientist? Currently, I'm machine learning data associate.
I'm sorry, can you repeat the question? I was not able to hear properly.
Hi, I'm working at Amazon.
Okay.
Yeah, I would like to transfer internally
Mhm.
as a data scientist or data analyst
Okay.
from my current role. Currently, I'm working ML data associate. Is there any way I can do internal transfer? And what kind of teams are looking for data analysts? And what kind of projects I could enrich, include in my portfolio to
Uh,
show in my
so
resume?
internal transfers are very much company specific. So I'll definitely not be able to guide you in terms of Amazon specifically. I've never worked in Amazon. I've worked in Microsoft and before that in Cummins. Um, but one thing in internal transfers, definitely you have an foot in the door already, right? Uh, make your profile as such what job needs are and work on that profile as in you can make projects which will tell the recruiter in the subsequent org that this person can be really good fit for because this person already knows so much about our stuff and this person already has a foot in the door. Uh, this can be a really good match for our team with respect to what are projects the person is doing right now. Um, that is something I feel internal transfers take into account more and do prepare for interviews because interviews will happen. So interviews are something I feel like a lot of people don't give more importance to interviews, but more importance to just the understanding of everything. Interviews are equally important. So give importance to interviews also. See what interview questions that come up, um,
Mm-hmm.
practice for interviews, and then apply for the roles.
I see. Mm, so, what would you suggest if, what kind of skills I should focus on studying for interviews? I know SQL.
Mhm.
Mm, is there any specific trend that currently interviewers are asking for?
It's very dependent on what the org really wants. Um, and that's very technical side of things. I've not discussed that in the slides, but it really depends on what you're working as a data scientist in. I, for one, used to go for everything because I'm in love in this field, so I used to go for everything. And what I used to do is I used to be over prepared for the interview. That was my strategy because when you're over prepared about an interview, you are more confident about an interview. Typically, talking about uh, very much highlighted skills, SQL is one of the great ones out there, definitely. Um, Analytical mindset is the key thing what uh, your interviewer will actually look into you. They will actually kind of judge your analytical mindset in their questions. They don't want mugged up answers coming out from your mouth, but they want that analytical thinking coming first and then the answers coming from your mouth second. That's the most important thing you can take away. Um, but I feel like everything is important. I cannot give kind of a an upper ranking to probability and lower ranking to statistics and lower ranking to linear algebra. Everything has its own importance. So give everything equal importance, work on it, work on the fundamentals as discussed in the slides, and that can be a good start for definitely. One good thing is maybe do a good course. That really helps. That can be a good starting point. I hope that answers the question.
Thank you.
Last round for questions. At 1 o'clock, we're going to be having another talk. And Dana, that the talk that is at 1 o'clock is from someone who's from Amazon. So if you want to stick around to ask him any more questions, you can. But
Oh,
yeah,
that I think I got,
yeah,
yeah, I got confused. I'm so sorry.
it's okay. We have one more question in the chat.
How is your time at Microsoft? Oh, it's not been long right now. I joined in Feb, so it's been like 2, 3 months already, just 2, 3 months. So, uh, but the work is good. I'm being a better data scientist than my previous day every day. That is what more is most important thing to me, I feel like. And I'm working in Xbox. That's quite cool per se. But I always wanted to work in user product database. And that's where I'm working in. I'm working in game pass analytics team. So uh, all the you can say pieces are in the right picture. Um, so I'm enjoying my time with it. That's definitely for sure.
Do you work in the Redmond area or which location?
I work in Redmond area, yeah.
Okay, nice. Anyone have any more questions? If not, thank you so much. Your talk was very helpful. I think everyone participating in the Datathon it's going to help their projects a lot. Thank you so much for your time.
Thank you. All the best, everyone, for the hackathons. Um, do give your best, and I would say learn from it as much as you can.
Thank you.
Okay. Thank you. Bye.
Bye. Everyone who wants to stick around for Doug's talk about the personalization of LLMs and his time at Amazon, you guys can stick around and we'll start soon.